Hello everybody, after a long time I am here again. Sorry for the delay. I hope all of you are in safe and best wishes to all of your families. Stay safe and keep safe in this pandemic time. Let us go to our session. I hope that you already watched the demonstration video of this second version of point insertion on polyline, and make sure you already created a function, the distance from points from the which we discussed on the previous session. In this video, we are going to discuss only about the properties of a polyline and how we are extracting the data to create equations for finding the insertion points. And these equations we will use in our macros to insert points. As you know, polylines are made of line and arc segments. So here we will go through each segments of polyline and insert objects. So here are two objects, one is line and an arc. So mainly we will make calculations for these two objects. We will find the which one is the line segment and which one is the arc segment, and then we will insert make calculations for each type object, then insert points. Let us see how polylines are defined in AutoCAD. Here we have a polyline with a line segment and an arc segment, that is with three vertices. Index number for the first vertex is 0, then next is 1, and next is 2. For a polyline vertex, we have only x and y values. So each vertex we have two values only. And for the z value, we have to consider the elevation of polyline. Now, when extracting the vertex points, we can use two functions in VBA. One is coordinate with index number. This function with index number returns the x and y value of a single vertex. So coordinate 0 means this when you extract the value using coordinate with a 0 index, it consists of two values. Then and there is another function, coordinates function, which returns the list of all values from all vertices in a polyline. That means total number of coordinates in a 3 vertex polyline will be 6, with the index number starting from 0 to 5. When you find the upper limit of coordinates, not coordinates, it will give you the total number of vertices in a total number of values in the polyline. So from this value we can find out how many numbers how many vertex in that polyline. In this polyline we have three vertices. So these three vertices total number of values will be 5. That is upper limit of the coordinates will be 5. So 5 minus 1 divided by 2 will be the index number of last vertex. First vertex is 0, then second vertex is 1, then third vertex will be 2. This is the index number of vertex, not the coordinates. Index number of coordinate, not coordinates. So using this index number starting from 0, we can access the coordinate points of each vertex, and at the same time we can access the segments in a polyline using this index number. So first vertex is 0, and first segment index number of the first segment will be 0, and the next vertex will be 1, and the next segment will be with the index number 1. Now distinguish the line segment and arc segment in a polyline. Here we discussed about coordinate points, x and y values. Then other than x and y values, we have another property, bulge. If bulge value is 0, then the segment is line segment. Then if bulge value is not equal to 0, then it is a curve. It may be counterclockwise or in clockwise direction. This bulge value we can retrieve it by using the getBulge function with the index number of the segments. Here first segment is a line. When you use getBulge function with the index number 0, It will return bulge value 0 as the first segment is a line. And for the next segment, index number will be, for the next segment, the index number of the segment will be 1. When we use get bulge index 1, it will return the value that is not equal to 0, which means it's an arc, either in clockwise or counterclockwise direction. If the bulge value is positive, then the curve is in counterclockwise direction, and if bulge is negative, then the curve is in clockwise direction. Now we are going to insert a point on a polyline. We consider the first point, that is the vertex 0, as the base point. Then from the base point, we will find the coordinate of the insertion point, that is at a distance of array spacing. Here we can use function polar point to find the insertion point. Polar point function requires a base point, then angle and distance. Base point is the vertex point, and angle is the angle of line segment, and the distance is the array spacing. Here each time we will keep the vertex point as the base point, and for the distance we will add the spacing each time to the distance to insertion point. Here base point and the distance are known. We have to find the angle of line segment. Angle between 2 points can be retrieved using function angle from x-axis, which needs 2 parameters, point 1 and point 2, which is coordinate 0 and coordinate 1. Here first we will find the total length of the segment, because we will insert point only if the length to point is less than the length of segment. If it is less than the segment's total length, then we will insert the point. Otherwise we will insert point on the next segment. To find this distance, we will use the new function which we created in the previous session to find distance between points. Next we will find insertion point on a curve. To insert point on a curve, first we will find out the center point of curve, then find the delta x and delta y of the insertion point from the center point and insert the point. First we have to extract the available data from the polyline. We have only 3 data, that is start point, bulge and end point. We can extract the start and end point of arc using the index number of vertex, and the bulge using the index number of segment. Here index number of the first vertex is 1, and the index number of the segment also the same. Using these points and the bulge value, we will calculate the angle of arc. Then using the angle, we will calculate the radius of arc. Then calculate the start angle of curve. Then using polar point function, we will find the center point. The polar point, point 1 is the coordinate point, and angle is the start angle, and the distance is the radius. Here now we will find out the angle of arc. Here we have to consider the property bulge. Bulge is the proportion of mid-ordinate and half of the chord length. That is, bulge is equal to S divided by C. From the figure you know that S divided by C is tan theta B. That is, theta B is equal to arc tan bulge. That is 1/4 of the angle of curve. That means angle of curve delta is equal to 4 times theta B. That is, angle of arc is A tan bulge multiplied by 4. Now we have the angle of curve. Now next we have to calculate the radius. First we will calculate the chord length from the 2 points, coordinate 1 and coordinate 2. We will use the function which we created in previous session, distance from points. Then the chord length is the distance from points, point 1, point 2. Consider the highlighted triangle. We have half chord length C and half of angle delta by 2. Then radius R is equal to C divided by sine delta by 2. Now we have the radius. Next is to find angle of the radial line. We need the start angle for the polar point function, that is angle of this radial line. Let us consider a curve in anti-clockwise direction. Then angle of its chord line will be theta C is equals angle from axis point 1, point 2. Here we will consider the blue triangle. We have the acute angles we calculate from the angle of curve. One is delta by 2 and other is pi minus delta divided by 2. So the angle of radial line is theta is 90 minus half delta plus the angle of chord. Now we can use the polar point function to find the center point of the arc. Now we have angle of curve, center point and radius. Now we have to find the insertion point at the given spacing. First we find the angle to the start point from the center point using angle from axis function. Then calculate the angle of arc for the given arc length. Here it is arc length is spacing. So the angle of arc is arc length divided by radius. This arc length we will increase the arc length each time by adding the array spacing. Then the angle to the insertion point is the start angle minus angle of small arc, that is delta 1. So then using trigonometric function we will find the x and y variation from the center point. Then add or subtract the x and y value from the center point. Here for each quadrant this plus and minus sign will changes for cosine and sine values. Here addition and subtraction will changes as the x and y value changes depending on the quadrant. That's all for today. In the next video we will create a macro from these equations to insert objects on a polyline. Thanks for watching. Don't forget to like if you think it is useful to you, and subscribe and click notification button to get notified for coming videos. Thank you.